We are in chapter 4 on home loans and more annuity problems, and now we're in section 4.2. This section is all about home loans, details, lots and lots of different things about home loans. So before we get started, we're just going to run through some of the formulas, okay? So some of these we've seen before, some of them are new. We just have to kind of keep track of them. So the first one is that the total interest paid is equal to the regular payment, R, times N, the number of payments, minus the amount you paid for the loan, A sub N. Okay? So again, this is the regular payments times the number of payments minus the loan amount. Okay? So putting it in words. Just so you have it. Okay? The next piece we need is the list price. Okay? So again, the list price, also known as the purchase price, is equal to the loan amount plus the amount of money that you put down. Okay? So that means that if we want to find the loan, then we would take the list or purchase price and we would subtract the down payment. Okay, so down payment. Okay, then we're going to deal with something called equity. So it's how much of your house you own. Equity is list minus owed. Okay, list minus owed. So it's a list price minus how much you owe. Okay, and then the percent owed is the equity divided by the list, okay? And then you multiply that, by your 100 to get the percent. Okay? Now, we've referenced this twice, but the amount that's owed, sorry, not owned. The amount that's owed, percent owed, owned, equals equity divided by list. So the amount owed is going to be our leftover formula. Using an N in the middle of the payments. Okay, in the middle. So what that means, just as a reminder, that was A sub N, so your loan amount times 1 plus I to the N. So this is again your loan minus your regular payment and then your S sub N. Okay, so this was equation 4.1, your book calls it. Alright, so we're going to look at an example of this just so you all see it all together. So we're going to do number 10. The buyer of a house obtains a loan of $90,000. So again, we're going to make our timeline automatically. We know that $90,000 is over here because that's a loan amount. The buyer can obtains a 15-year loan, so we know it's for 15 years at 5.4% interest, so our R is 0.054. Monthly, so that means I is 0.054 over 12. Or we could do a 30-year loan. So we have two cases here that we're looking at. So again, $90,000 is still the loan. 30 years. And then here our R is 0.0585. And then again, that's monthly. So R is going to be 0.0585 divided by 12. And we want to find the monthly payment for each and the total amount of interest paid. So first we have to find monthly payment and then interest paid. Okay, so we're making payments each month. And again, when we do our timelines, we want to do the first two payments to show how far they are apart, and then the last one okay. So here we're not necessarily using all the stuff, but we are going to use that total interest paid, which was up here again. So it's going to be our R times N minus A sub N. So we'll have all those pieces with us. Okay. So let's look at the first one. Let's look at the 15-year mortgage first. 15-year mortgage first. So when we look at the 15-year mortgage, we're gonna have to figure out how many payments are made. Okay, so if we're doing 15 years times 12 payments a year, on our calculator, we get 180. So when we set this up, we get 90,000. That's our A sub n. That's A180. It's going to be equal to our regular payment times 1 minus 1 plus our I, 0.054 over 12, to the negative 180 divided by 0.054 over 12. So again, I'm approaching it the same way that we've been doing stuff. You could absolutely just use a straight R formula. That's fine. It's the same process. So I'm going to do 1 minus 1 plus 0.054 divided by 12 to the negative 180 over 0.054 over 12. And we get 123.18 and change. So I'm going to divide by 90,000 by that answer. Because again, I'm not going to round. So here my regular payment would be $730.61 because we round up the payments. Okay, we round up the payment. And now we're going to have to find the total amount of interest paid. So that's going to be total interest paid. This is going to be 180 times R. 180 was our N from up here. So that's where that comes from. Minus our loan amount, $90,000. So we get 180 times 730.61 minus 90,000. So when we plug that in a calculator, you can do that all at once. And again, you want to use your rounded up payment, because if you just use your previous answer, you're going to be off a bit. So you want to use what you actually found for R. So that means for this 15-year mortgage, we would pay $41,509.80. Because again, we're going to round to the nearest penny, so we have to go to 2 decimal places. Okay, so that would be our total interest paid. So go ahead and take a minute and try to find the second part. Alright, so now you've had a chance to try it. We're just going to run through it, so I'm going to set it up the same way. First thing we have to find is the number of payments. So we get N equals 12 payments a year times 30. So 360 payments. Because again, that's 30 years times 12 payments a year. That's where we're getting those two numbers. So that means A 360 would be that 90,000. So then we get 90,000 equals R times 1 minus 1 plus 0.0585, because here we have a different rate. So negative 360 over 0.0585 over 12. So I'm going to find that coefficient just like we did before. So there's my numerator, and I'm going to divide that by my denominator. So we get 90,000 is equal to R times 169.50 and change. Divide 90,000 by that. So here our regular payment is significantly lower, $530.95, because again we're going to round up. Okay, so there's the first part. But then to get our total interest paid, we're going to take this number, and this time we're going to multiply it by our N. Our N here was 360, so it's going to be $530.95 times that 360, minus again our loan amount, which was 90,000, So this time the interest we pay is $101,142. So we've almost paid the loan twice with the interest just because it's so long. So what this tells us is that if we can swing the higher mortgage payment, it will be better in the long run because it would save us 60 grand.